Next bit, the structure of a simple sugar is shown. You make starch by polymerization of simple sugar. You kick out a small molecule such as water. So there are two types of polymerization, right? There's addition and condensation. So when you kick out a small molecule like water, that is definitely not addition. Because when you have addition, you will have like things like this. I don't know. I'm showing the most basic example where you have n number of that, and then you can get. Make sure you have an open chain to show the carbon from 4 bonds, and you don't kick out any small thing. You just keep on adding. You lost a double bond and you form an open chain like that. Yeah. Okay. Now they want you to show at least 2 repeat units. And how does starch look like? You know, when you have another one here, what is going to happen is this. You should probably draw another one. Right? So the condensation, they told you they will kick out water. Alright? So imagine if this one lose the OH, that means this one will lose the H. Alright? So that will give you H2O. You don't lose OH and OH because then you won't kick out H2O. Alright? So because this one lose the OH, this one lose the H, so this one will have to lose the OH, and this one will lose the H, and that will kick out another water. So what do you get then? I'm not going to draw it to scale, but what I'm going to show is that, like that. It has to be open chain. Okay, so that is essentially that is 1 unit, because you have 2 OH, right? So there's essentially 1 of that, and you need 2 of it. So this is the second unit. I hope you can see 2 repeat units. That is 1 of it because it has both ends. Alright, and then you have got to show both open end because they are no longer bonded to H or something else, because they are now part of the polymer. The starch is formed by polymer, so polymer has to be open chain, yeah, just like that, to show the continuation on either side. Yeah. Now you want to convert starch into simple sugar, so this is breaking down of the starch into simple sugar. So this is a process called hydrolysis, and I hope you know that you can use dilute HCl or dilute H2SO4. So those are the common acid you use, but what is important is you need heat. Alright, but you can use any of the dilute acid conditions, and then you need heat to hydrolyze starch or to hydrolyze proteins or to hydrolyze fats. These are the typical acidic conditions together with heat that we use for hydrolysis. Yeah. Now next bit, they want you to draw a ring around all the atoms in 1 ester linkage. So you just need 1 ester linkage. So there's 1 ester linkage, all the atoms in the ester linkage. There's another one you can draw there. This will connect to this, so there's actually another one there, but it's hard to see it. So you can draw that or that, but you just need 1. Alright? Anyway, so now you want to deduce the formula of the molecule eliminated. So the idea there is okay, so there's only 1 molecule that's being eliminated when you polymerize simple sugar. So this bit you can think of it as like alcohol. When you go to form that, it has lost that, but it doesn't exactly lose that. It's like when you have another one of it, it will lose that and that. It will lose water. Only when you lose the OH, then this bit will be bonded to this oxygen. You see that? Yeah, okay, so there's only 1 oxygen because this second bit lose that, and then this one will lose the H, and then the second bit will lose the OH, and so on and so on. Okay, so it is a condensation again. It is a form of condensation polymerization because you eliminate small molecules, yeah, such as water. So now you want to hydrolyze starch into simple sugar. You need the reagent and the conditions. Okay, so you can be thinking about like acidic conditions, so dilute HCl or dilute H2SO4. So dilute HCl will also work, but this reaction will not work unless you have heat. You need to heat it, otherwise they will not be hydrolyzed. Okay, hydrolysis takes place in the presence of heat. Yeah. So dilute HCl, dilute HNO3, dilute H2SO4, they're all dilute acid that will work. Okay. Next bit, amino acid alanine can form polymers, so they want you to draw a circle around all of the atoms in one amide. So we know that is amide. Okay, there's another amide there around all of the atom in one amide. Okay, so I do not need to draw another one, but that is another amide there. Okay, can you see that? And there's the repeating unit there, so there's actually another NH there and another amide there. Okay, now they want the monomer. Okay, I hope you can see the repeat unit is actually, so there's the amide, right? So there's the bond that you form when you form the amide in the polymer. So this is the bond that you form. So that was previously the carboxylic acid, that was previously the amine, NH with another H. Alright, so this loses a H, this loses a OH, it loses H2O. Just like that, condensation, polymerization, yeah, okay. Anyway, so from day to day, it's actually one repeat unit. Okay, one repeat unit. So I could draw the monomer like this. CH, CH3, COOH. Okay, alright. So next question, proteins are natural polymer. Name one other natural polymer. Starch or polysaccharides or complex carbohydrate will be alright. But starch is nice and easy. So proteins can be hydrolyzed to amino acids. So if in the body is in the digestive system, that will be using enzymes present, right? That's how you digest proteins to amino acids from the food. But they did not specify it's in the digestive system. So this is by chemical method. So this is not inside the body. And hydrolysis of protein to amino acid, you can do it by heat protein with dilute HCl, or you can use dilute H2SO4, and that way you can just get the amino acids. Alright, any dilute acid will do. The structured amino acid is shown there. You can polymerize it because it's got two different functional groups there. So imagine you have H2N and CH3, COOH. Imagine you have another one here. Sorry, CH3 there. And COOH. What you're going to form is the carboxylic acid will lose the OH. You will lose the H there. You will lose the OH and you will lose the H there. So minus water. So definition of condensation, polymerization, right? So you want to show two repeat unit. It's better to start from the amide bond first. So this thing there refers to CONH. Okay. So now I'm going to continue here first, which is here. CH3, C. You gotta display the amide. So this is the next amide, C double bond O, NH. Okay, CH3, C double bond O. And then it's a polymer, so you have to continue it. But you only want two repeat units. So let me think. So if you start from here, there to there is one unit. There to there is another unit. So I do not want this, okay, because there's more than required. But I must leave this open. I must not have a hydrogen there because it's a polymer already. Same thing there. I should not have a OH. I should not just have 1, 2, 3 bond. I must have carbon forming 4 bond, but this is open and this open. Okay, the nitrogen form 3 bond, 1, 2, 3. This connects further to the chain. This connects further to the chain. You can see one unit of alanine, another unit of alanine. Next bit here, serine can form polymer with amide. Serine can also form polymer with a different linkage. So you know this and this can form amide. So green can give you CONH amide. I'm going to use a different color, red. This and this, and this essentially can give you C double bond or O, there's your ester. Okay, so ester is the other linkage. So serine has, so explain how it's formed. So serine has amine, which is the NH2, carboxylic acid, which is the COOH, and alcohol, which is the OH. The COOH and the OH ends of serine, of different serine molecules, can form ester, C double bond O, like that. Okay. Next bit is a bit of organic chemistry. So they want you to draw polypropene. They give you the monomer. You know, in the polyalkene, you lose the double bond, and then you will have open and open end because you will form polymer. So most common mistake is people just draw like this, and your carbon doesn't form 4 bonds. You have 1, 2, 3, and carbon will form 4 covalent bond because carbon has 4 outer shell electrons. It will share 1, 2, 3, 4, form 4 covalent bond. Yeah. Next bit, you want to show complete combustion of polypropene, but they say use the empirical formula, which is CH2. So just draw CH2 and then react with oxygen. Complete combustion will give you CO2 and H2O. Only 1 carbon there, so only 1 carbon there. 2 hydrogen, 2 hydrogen, 2 oxygen plus 1, there's 3 oxygen, but there's 2 there, I cannot change that number. How do I get 3 here altogether? I just do 3 over 2. 3 over 2 times 2 is 3. Some people, they really don't like, when I say some people, I mean this includes students and teachers, they really don't like half. I don't know why. I personally like to balance equation with half because it's nice and easy. Just showing you that I have 2 oxygen and 1 oxygen. I could do 3 over 2. In Cambridge will never penalize you if you do 3 over 2 because that's perfectly fine. 3 over 2 oxygen on its own is not fine, but when you have the molecule, they are fine because they do balance out. Alright? You can also multiply the whole thing by 2, then you will get 2, you get 3, you get 2, you get 2. Also fine. Whichever one suits you. Okay? Suggest an advantage of a plastic that's biodegradable. So biodegradable means it can decompose in nature. It can break down, okay, into simpler substances. So you can think about a plastic which is not biodegradable. It's going to linger around. It's going to stay around, for like hundreds or thousands of years. So it will not rot away. So really there's going to be a problem, you see, okay? So the thing which is biodegradable is that it can decompose. It can decompose or it can break down into simpler substances and therefore will not stay for a long time. Wouldn't be an eyesore, wouldn't fill landfill, so your trash site wouldn't have a lot of plastic there because they will decompose on its own. Wouldn't be eyesore. Or really, I've just put in a lot of points, but the idea really is what is biodegradable and therefore why are they good. Okay, that's the most important idea. Next bit, they talk about condensation polymer here. So I hope you can see this is the ester linkage. And then here, this is the one that continues. So there's your open and open end. Just like we have an open and open end to show polymer. This is a condensation polymer, okay? So there's actually another of this unit here. So there's actually another ester there. Okay, so here they say draw the structure of the monomer. They don't say monomers, they say the monomer. So there's only one, singular. Alright, so you can think about oh yeah, okay. You know that when you form this ester, this is the new bond that you form. That is the new bond that you form. This is actually a carboxylic acid to begin with. And you can tell that they have shown you 2 repeat unit there. So there's 1 repeat unit, because here you get another one repeat unit. Can you see O, CH2, CH2, CO, C double bond O. So that is actually 2 repeat unit there. So one repeat unit is going to be, this is the part that form the ester, this is the alcohol, because that's the bond when you break, that's the alcohol, and this is the carboxylic acid base because it has a C double bond O. So what I'm doing is, I am just drawing out the most obvious bit, the acid with the one that contains the C double bond O, the alcohol from the other end there. Alright?